In this video, I want to show you how we can find integrals of some rational functions with the completing the square method. Let us start with this simple example. What is integral of dx over x to the 2 plus 6x plus 9? In the denominator here we have a quadratic expression. And immediately we can see that we can write x to the 2 plus 6x plus 9 in the form of x plus 3 times x plus 3. Attention, 3 times 3 is 9 and 3 plus 3 is 6. So we can write this quadratic expression in the form of x plus 3 times x plus 3. This way we can factor that quadratic expression. But because the two factors are the same, so we can write this in the form of dx over x plus 3 to the 2. For finding this integral, we can bring x plus 3 to the 2 to the numerator and write this as x plus 3 to the power of negative 2. So we can write this in the form of x plus 3 to the power of negative 2 dx. And now, if you remember the power rule for integral of u n du is u to the n plus 1 over n plus 1. By using this formula, we can find this integral right away. And you don't need really to do any substitution here. If you want, you can name this bracket u and immediately dx would be du. But it's not really necessary to do this substitution. You can apply the formula right away here. So what is the answer of this integral? X plus 3 to the power of negative 1. We add 1 to the power and same power in the denominator. And don't forget to add the constant at the end. If you want, you can write this answer in the form of negative 1 over x plus 3 plus c. Because the power of x plus 3 is negative, we can bring it down to the denominator and write it in this way. And because we have a negative in the denominator, we can move that negative to the numerator and write the expression in this form. So the integral of dx over x to the 2 plus 6x plus 9 is negative 1 over x plus 3 plus c. Now let me show you another example that is a little harder, of course. What is integral of dx over x to the 2 minus 4x plus 13? In the denominator, we have a quadratic expression. And if you attention, this quadratic expression is irreducible. Basically, it means that you cannot factor this expression in the denominator. If you try to factor it, you are not going to be successful. You cannot find two numbers that their product is 13, their sum is negative 4. So we have to think to another way, another method. What is that method? Completing the square. When you have a quadratic like this in the expression, in the denominator, and you don't have its derivative in numerator, attention, if the derivative of this is in the numerator, then we can choose this as u, and then du is here, and then you can integrate with the formula of integral du over u is ln of u. But here, because the derivative of the denominator is not in numerator, so that method doesn't work. And the only choice that you have is completing the square. So first, we have to try to write this quadratic expression in the form of a complete square. For that, if you remember, we divide this coefficient of x by 2. Negative 4 divided by 2 is negative 2. We raise that to the power of 2. So negative 4 divided by 2 is negative 2. Raise negative 2 to the 2, 4. So we add 4 and we subtract 4. Because we don't want to change the expression. And don't forget to put 13 at the end. Now, for this, we can write this in the form of x minus 2 to the 2. Again, half of this number goes here. Divide negative 4 by 2. And negative 4 plus 13, this equals to negative 4 plus 13 equals to 9. So we converted this expression to this form, which is better for finding the integral of questions like this. So, in this integral, we have integral of dx over x minus 2 to the 2. And if you want, you can write that 9 in the form of 3 to the 2. But what we have to do here, let me remind you an important formula for finding integral. integral of du over a squared plus u squared or u squared plus a squared is 1 over a tangent inverse of u over a plus c, which a is a number. In this particular question, the 3 is or a and x minus 2 is u. So this equals to 1 over a 1/3 tangent inverse of u, which is x minus 2, all over a 3 plus c, and this is the answer of this integral. Please pay attention. Here you don't really need to do any substitution, u substitution. You don't need to substitute this by u, then calculate du, which would be dx. You don't need to convert this exactly to this form and then use this formula. You can apply the formula right away. Because if you choose the bracket x minus 2 as u, if you choose u to be x minus 2, immediately by taking derivative from both sides, you can see that du is dx. And so this plays the role of du over u to the 2 plus 3 to the 2. So it's not really necessary to do the actual substitution. Apply the formula right away to the integral and find the answer. Let's see another example. Here we have integral of 2x plus 7 over x to the 2 plus 2x plus 5. This is different from previous questions because if you pay attention, we have an expression in the numerator. We have 2x plus 7 and it is part of numerator is derivative of the denominator. So please pay attention. Here, if we choose this as u, the derivative of this is exactly in numerator. So here, if we choose the denominator u, if we choose u as x to the 2 plus 2x plus 5, then du is 2x plus 2 dx. And in the numerator we have 2x plus 7. It's not the same, but it's almost the same. The only difference is that here we have 2, in the actual question we have 7. But we can write 2x plus 7 in the form of 2x plus 2 plus 5. So here, first we write this integral in the form of 2x plus 2 all over x to the 2 plus 2x plus 5 dx, then plus 5 over x to the 2 plus 2x plus 5 dx. So we split the integral to two other integrals. But attention, because the denominator is the same, if you add the numerators, it's the same integral that we had in the beginning. Now, for our first integral here, the derivative of denominator is exactly in numerator. And for finding this integral, you can do u substitution. But let me show you a trick that you can use. It makes finding integrals sometimes faster. Whenever you are finding integral of a fraction, if we say, let's say the denominator is u, if the derivative of u is in the numerator, derivative of u prime is in the numerator, then the answer of that integral is ln of the denominator, ln of u. For example, let's say we have 2x over x to the 2 plus 9 dx. What is the answer of this integral? Normally, we suppose this as u, then we have to calculate du, substitute, and then you can find the integral. And at the end, you have to substitute back. But with this technique, for a moment, we look at the denominator and we say, okay, if the denominator we suppose in our head is u, what is the derivative of denominator here? The derivative of x to the 2 plus 9 is exactly 2x, which is in the numerator. So the answer of this integral is ln of x to the 2 plus 9. You don't need to actually do any substitution. Another question. Suppose you want to find integral of cosine x over sine x. The derivative of sine x is exactly in numerator. And because derivative of the denominator is exactly in numerator, what is the answer of this integral? ln of sine of x. Derivative of the bottom is in numerator, so the answer is ln of sine of x. If you want, yes, you can choose the denominator as u, then take du, substitute, and so on. But this method, which I showed you here, is faster. And of course, if you want, you can put absolute for sine here to make your answer better. For ln of sine of x or ln of absolute of sine of x. Now let's back to our question. Here, in this question, in the first integral, derivative of denominator is exactly in numerator. And because derivative of denominator is exactly in numerator, what is the answer of this integral? This equals to ln of x to the 2 plus 2x plus 5. But what about the other integral? For that, we don't have the derivative of the denominator in numerator. For that one, we have to write the expression in denominator in the complete square form, and then we can find the integral. So first we have to do something with the denominator, x to the 2 plus 2x plus 5. For this expression, we write x to the 2 plus 2x. To write this in the form of a complete square, we divide the coefficient of x by 2. 2 divided by 2 is 1. 1 squared is 1. So we add 1 and we subtract 1. Don't forget the 5 at the end. Now, these three terms can be written as x plus 1 squared. Where this 1 comes from, divide this number by 2. And negative 1 plus 5 is 4. So, plus 4. So this expression here, this expression can be written as x plus 1 to the 2 plus 4, which can be written as 2 to the 2. Again, let me remind you the formula. Integral of du over a2 plus u2 or u2 plus a2, doesn't matter the order, is 1 over a, which is a constant, tangent inverse of u over a plus c. Use this formula to find that integral. First of all, attention, what we have to do with that 5. We can move it to the outside. It's a number, it's a coefficient, so it's completely okay to move it to the outside. So, the answer of this integral is 5 times by, now use this formula. 1 over a. What is a in this example? 2 to the 2 is a to the 2, so a is 2. So 1 over 2 tangent inverse of u, which is x plus 1, all over a, which is 2, plus c. And 5 times 1/2 is 5 over 2. So this is the answer of this integral. And let me explain to you something. Maybe you wonder why I didn't put absolute for this expression. Because in the formula for ln of u, in the formula integral formulas, we have an absolute. Because this expression is always positive, when something is positive, you don't need to actually put any absolute for that. But if you want, you can put the absolute, because maybe you are not sure that that expression is positive or negative, and so on. You don't need to make your solution complicated for yourself. So this was a challenging question, basically. Now let's take a look at a harder example even. What about this? Integral of x plus 1 over x to the 2 minus x plus 1 dx. In this question, again, because we have something in numerator, we have x in the numerator, we cannot immediately start by writing the denominator in the complete square form. So, before doing that, we take derivative of the bottom. We suppose the bottom as u. For a moment, we suppose u as x to the 2 minus x plus 1. du would be 2x minus 1. But we don't have 2x in numerator. We have to do a little algebra here to make numerator, to write numerator in this form. Here you have to apply a little algebraic techniques to be able to write that in the proper form, in the form of 2x minus 1. Let us start. When I look at du, I notice that I need 2x minus 1 in numerator. But I have only 1x in numerator. I don't have 2x. So I solve this problem with multiplying numerator by 2. So this is the thing that I'm going to do. I multiply numerator by 2. So we write the denominator. We multiply numerator, which is x plus 1, by 2. So we have 2x plus 2 if we multiply by 2. But when we multiply this by 2, we have to put a 1/2 outside to cancel the effect of multiplying by 2. Now if we multiply 1/2 in this bracket, 1/2 times 2, 1/2 times 2 cancel, and it's the same expression that we had in the beginning. But I know that I don't need 2x plus 2, I need 2x minus 1. So for that reason, I change this plus 2 to minus 1. But am I allowed to do this? Of course not. The question was x plus 1. How come you can change x plus 1 to 2x minus 1? Now I fix this with adding a proper number here. Please pay attention. What we have right now in the numerator? We have 1/2 times 2x minus 1. So I put this expression exactly in numerator. And then 1/2 outside. Multiply this 1/2 in the bracket. If you multiply 1/2 in the bracket, you have 1/2 times 2x is x. 1/2 times negative 1 is negative 1/2. So this is the thing that already we have in this numerator here. But what we had in the question, in the actual question, we had x plus 1, but this is x minus 1/2. So now you should be able to figure out the number, the constant that we have to add to the numerator to make this equal to that. X is fine, we have x here. Negative 1/2 should be 1. What number we have to add here? Negative 1/2 plus 3 over 2. Because negative 1/2, please pay attention, because negative 1/2 plus 3 over 2 is exactly 1. Negative 1/2 plus 3 over 2, this equals to 2 over 2, and 2 over 2 is 1. Let me review the process again. When we looked at this question, we suppose the denominator u, derivative of denominator is 2x minus 1. We look for 2x minus 1 in numerator, but we don't have 2x minus 1. We have something completely different. For that reason, we write 2x minus 1 in a bracket, and we put a proper coefficient outside that makes the x at least equal to the x that we had in the question, original question. But by doing this, we have a problem, and that problem is about the number. 1/2 times 2x minus 1, which we have right now here, is exactly x minus 1/2. But we had x plus 1, so we have to add a 3 over 2 to the numerator. So let me erase these from here. By adding a 3 over 2, now the numerator is written in the proper form. For the last time, let me explain. 1/2 times 2x is exactly x. 1/2 times negative 1 is negative 1/2, which plus 3 over 2 would be 1. So numerator is the same numerator, but written in the proper form that we need. But what we have to do with this integral, with this new form? Now we separate numerator over denominator in this way. We write this in the form of integral 1/2. You can move the 1/2 to the outside, which I will do in a moment. 2x minus 1 all over x2 minus x plus 1. And the other integral plus 3 over 2, which again you can move the 3 over 2 to the outside, over x to the 2 minus x plus 1 dx. Here we did nothing, just we separated numerator over denominator. numerator over denominator. For the first integral, if you notice, the derivative of denominator is exactly the expression in numerator. And it's better to write this 1/2 in the outside of this integral. It makes the question better. Now, let me repeat this again, and I forgot to write the x here at the end. Derivative of the bottom is numerator, again with the same technique in the previous question, because derivative of denominator is in the numerator. This equals to 1/2 ln of the denominator, x2 minus x plus 1. For the other integral, we can move the 3 over 2 to the outside, and then we have integral 1 over x2 minus x plus 1 dx. For finding the integral of 1 over x to the 2 minus x plus 1 dx, again we have to use the complete square form technique. So we have to write x to the 2 minus x plus 1 in a proper form, in the complete square form. To do that, we write x to the 2 minus x. Half of the coefficient of x. The coefficient of x here is -1. Half of that would be -1/2. S square 1/2. 1/2 to the 2 would be 1/4. So we add a 1/4 and we subtract 1/4. And don't forget you have 1 at the end. This equals to x2 minus x plus 1 over 4 as a bracket, and -1/4 plus 1 is 3 over 4. So this is 3 over 4 plus 3 over 4. The first bracket can be written as x minus 1/2 to the 2, and 3 over 4 can be written as radical 3 over 2 to the 2. So we can write this expression in the form of x minus 1/2 to the 2 plus radical 3 over 2 to the 2. For finding this integral, again we use same formula that we had in the two questions before. du over a2 plus u2 is 1 over a tangent inverse of u over a plus c. So finally, for this question, the answer is 1/2 ln of x2 minus x plus 1 plus 3 over 2 times 1 over a. But a here is radical 3 over 2. So 1 over radical 3 over 2 tangent inverse of u, which is x minus 1/2, all over radical 3 over 2 plus c. And this is the answer of this integral. I hope by watching this video you have learned completing the square technique for finding integrals of rational functions. When we use this technique, but when we have quadratic expressions like this one in the denominator that are irreducible, which means that they are not factorable, you cannot factor them, you need this technique for finding this type of integrals. If you like this video, please subscribe in my channel, and see you in the next videos.